Students, we are going to talk about magnetic field due to a current through a circular loop. Earlier we used to study about a straight wire which was carrying a current, and we found a magnetic field which was getting generated around the current carrying conductor. Now assume one straight conductor. Now we are going to just wound it in the form of a coil. We are just turning it to make a coil. That is a circular loop. We will make a circular loop and find out which type of magnetic field is getting generated. Let us talk about a circular loop which is carrying a current. Now this is a circular loop which is going to carry a current. Now if you want to find out the direction of magnetic field, first of all you should use right hand thumb rule. Now you can see here, if we select a particular point and if you use right hand thumb rule, then the direction of magnetic field lines produced at this point or at any point can be mentioned. So by using right hand thumb rule, you can consider many points where you can find out concentric circles getting generated. Now here in this circular loop, if we consider concentric circles, then from this distance, if we move away from that point, let us say we are moving towards the center of the loop, the concentric circle's arc is becoming smaller and smaller. That means there is less curveness in the magnetic field lines as we are moving toward the center of the coil. As each of the points are contributing for magnetic field, and each and every point which is contributing for magnetic field is representing the same direction, you can see that in center the magnetic field is near about straight lines. So we can consider that the current's direction. As we can see here, the current is flowing from this direction to this direction. It is entering from here and coming out from this direction. Now you can consider right hand thumb rule and point out the direction of magnetic field, and we can check the curveness from this point towards the center of the coil. The curveness is becoming less and near about a straight line. Now I would like to tell you, so let us say if there are n number of turns like this coil and current is entering and leaving the coil, then each and every turn from which electric current is passing contributes for magnetic field. So if there are n number of turns in a coil, then n numbers or n magnetic field, n times magnetic field, each and every turn will add up for magnetic field.
We have seen the pattern of the magnetic field lines produced around a straight wire carrying current. Suppose we bend this wire in the form of a circular loop and a current is passed through it. How would the magnetic field lines look like? Let's check this out. We have taken a circular wire connected in an electric circuit and a sprinkler with iron filings. Sprinkle some iron filings around the coil and insert the plug key to close the circuit. Current starts to flow in the circuit through the coil. We can observe the pattern formed by iron filings. Iron filings are aligning themselves by the magnetic field experienced at each point. we can see that the concentric circular magnetic field lines are becoming straight at the center of the loop. By applying the right-hand rule, we find that every section of the wire is contributing to the magnetic field lines in the same direction within the loop.
Download Spark Learning app.